Recently, as I was flipping through my books, I stumbled upon a sentence that stopped me in my tracks. It said the human brain, with its 83 billion neurons and the trillions of connections, is the most complex system in the universe. The most complex system in the universe. This is a conclusion reached by a human brain, read by another human brain, and right now, this very idea is being watched and processed by yet another human brain through this video. We are using the most complex system in the universe at this moment. The book mentioned 83 billion neurons, but some studies suggest that this number could be closer to 100 billion. It's roughly the number of stars in the Milky Way galaxy. And just like a vast network, these neurons are intricately connected to each other. Now I'm going to show you something even more interesting. On one side, let's look at this neurons web. And on the other side, let's look at the cosmic web. Do you see the similarity? Which of these images belongs to the brain and which one represents the universe? One of them shows the synaptic connections between neurons and the other, its galaxy clusters with the matter and dark matter filaments connecting them. So what can we conclude from the similarity? A philosophical idea that the universe is nothing more than a thinking, interconnected, living brain. Or maybe poetic idea, I carry entire universe within my mind. But what about scientific conclusion? For that, we need measurements. Two scientists, one astrophysicist and a neuroscientist, decided to compare this similarity numerically. In our brain, neurons are connected via axons and dendrites. And right now, as you watch this video and learn something new connections are forming in your brain. The approximately 100 trillion connections you have built so far in your lifetime shape who you are. These connections help you to make the sense of the world, evaluate the people around you, and shape a worldview. Now, let's create a universe view. Because at the end of the day, the universe is also a network. The observable universe is about 90 billion light years across and contains trillions of galaxies. Nearby galaxies cluster together to form groups, and these groups connect to even larger structures. These vast formations are linked by filaments of matter and dark matter. The universe appears to be structured like a massive web, just like the neural network in our brain. Is this resemblance just a coincidence? Or do the brain and the universe follow the same fundamental principles? To answer this, the scientists compared a 4 micrometer thin slice of the brain's cortex to a 25 megaparsec thin slice of the universe. Don't be fooled when I say thin. A parsec is 3.26 light years. Compared to the fragments taken from the brain, they are quite thick, but there is a certain ratio between them. When we look at the brain from different distances, these similarities are not immediately obvious. But at a certain zoom ratio, interesting similarities emerge. On the left, you see a section of the human brain magnified 40 times. Each side of the image measures about 1.5 millimeters. And on the right, each side of the section taken from a cosmological simulation measures 300 million light years in length. To measure this resemblance, the researchers used two techniques. First, they analyzed degree centrality, the length and angles of network connections. In the brain, a neuron's nucleus is small, but its axon and dendrite connections are long. The universe works the same way. Galaxy clusters are small, but the filaments connecting them are massive. And the second, they measured the clustering coefficient comparing the organization of network structures. Look, we can observe network structure everywhere. In the branch of trees, the formation of clouds, or in the turbulence of water. However, this biological and physical network structure manifests in nature as fractal geometry. So no matter at which scale we look, it appears to repeat itself. However, the human brain and the universe are not like that. When you look at them at different scales, they can appear completely different. That's why the researchers concluded their thesis with this sentence. The tantalizing degree of similarity that our analysis exposes seems to suggest that the self-organization of both complex systems is likely being shaped by similar principles of network dynamics, despite the radically different scales and processes at play. What does it mean? Of course, a brain and the universe are formed entirely different processes. In one, biology plays a significant role, while in the other, gravity is a dominant force. Yet they both evolved in strikingly similar ways. For example, 77% of our brain is water, and 73% of the universe is dark energy. But do you know what I find the most striking similarity? Do you remember that slide taken from the universe? After all, it's not a photograph. It's a computer simulation created based on data. Interestingly, the amount of computer data required to map simulated universe models is roughly equivalent to the memory storage limits of the human brain. Do you remember how I told you that similarities emerge at a certain scale? To simulate evolution of the observable universe at scales where the cosmic wave becomes visible, 1 to 5 petabytes of data are required. We are talking about an average of 2.5 to 3 petabytes of information. It's estimated that the total storage capacity of the human brain is also around 2.5 petabytes. Theoretically, if it wanted to, a human can store a significant portion of the observable universe's structure within their brain, or vice versa. Again, theoretically, the cosmic wave can store the data of a human's lifetime of experiences. Unbelievable. Then we can keep drawing both philosophical and poetic conclusions. We are trying to understand the universe with its all connections. Right here, in the tiny universe, in our heads. And there, billions of neurons reach out to billions of stars.